The history of all life begins in the sea, and we are water dependent still. On the great salt oceans, of course, but more directly on the rain, the rivers, the water in the ground. In large parts of the world, the life-giving rains are not spread over time, but acutely seasonal, linked to the onset of the monsoon, the change of wind, a critical event, an annual appointment with destiny. That means renewal, fresh crops, fast rivers, power. Or if too late or too little, famine, dryness, death. An enormous economic force, and in personal terms, so central, so pervasive, that to half the population of the world, the monsoon is the most memorable experience of their lives. And when the monsoon time draws near, after months of waiting, parched, receptive, and expectant, they prepare. In late 1978, also prepared and expectant, was a special meteorological task force mobilized to study the monsoon in Southeast Asia and then in India. It was called MONEX, the Monsoon Experiment. Director of the MONEX Project Office at the National Center for Atmospheric Research in Boulder, Colorado, is Dr. Joachim Kürtner. For many years, scientists have realized the importance of looking deeply into the critical monsoon phenomena, especially in the context of global circulation.
It is well known that the nations living in these areas are dependent on the monsoon for their livelihood and even for their survival. And it is understandable that these nations would like to see predictions of the onset of the monsoon, the timing, and the intensity of the monsoon rains. But unless the mechanism of the monsoon is fully understood, and especially its interaction with the world weather, such predictions will not be possible. In turn, the weather and the predictions of weather in other areas of the world are affected by the monsoons themselves. And it is for this reason that many nations far away from the monsoon areas, such as the United States, are participating in the monsoon experiment, MONEX.
In essence, the monsoon is a result of the difference in the way that land and sea respond to the radiance of the sun. In the summer hemisphere, the tropical land masses heat quickly. The tropical seas, with a greater heat capacity and ability to mix to greater depth the heat absorbed, remain relatively cool. The resulting temperature and pressure differences induce a flow of air from cooler oceans to warm continents, modified by the turning of the Earth. Monsoon flow often draws air from across the equator. As winter comes, land masses also cool much faster than the oceans, bringing about a flow from land to sea. During the winter monsoon, these effects combine dramatically over the South China Sea. The land masses of Malaysia, Indonesia, and Australia are heated. A deepening cold spreads through northern Asia. Siberian air begins to flow southward towards Malaysia and the Indonesian islands. Vast waves of air move at high levels from west to east across the Asian continent. Their troughs trigger strong surges of the winter monsoon. These may form a vortex over the South China Sea, which develops into a tropical depression. Deep clouds are generated and move westward, bringing monsoon rains to dry lands. These are general concepts. Little is known about the specific factors that determine the timing and intensity of the monsoon. The purpose of Winter MONEX was to explore these factors and improve prediction of drought and flood in this area. By late November 1978, as the winter monsoon season began, over 180 MONEX scientists and technicians had gathered at the International Operations Center at Kuala Lumpur under the leadership of Dr. Ho Tung Yuen, director of the Malaysian Weather Service. Available on site were pictures from the Japanese geostationary satellite and from the U.S. Tyros N polar orbiter. A stream of meteorological reports from weather stations in Asia and other parts of the world allowed the operations team to watch developing events in a global context. As the first outbreaks of cold Siberian air moved south, the intense experimental observations began. Throughout December, the U.S. weather radar system installed at Bintulu scanned the sky north of Borneo to monitor and record the development of rain clouds over the South China Sea. 3 Soviet ships stationed there launched instrumented balloons on a regular schedule. Most important were the research aircraft committed to the experiment. Equipped to capacity with sophisticated electronic sensors and able to drop radiosonde probes over areas that were normally unobservable, these aircraft were a major part of the operation. Flight tracks for the aircraft were developed almost daily at the MONEX Kuala Lumpur headquarters. They served to explore the cold surge and vortices over the South China Sea, the airflow and cyclone development near Sumatra, and the disturbances over the Java Sea. There were also research missions over the jungles of Borneo and Malaysia. The rains came. By the end of the month, the first MONEX observation period was over. The tremendous amount of data gathered would not only improve forecasting of monsoon rains in this area, it would affect the concepts of the monsoon mechanism and enable them to be understood better than ever before in the context of global circulation. Now, with the end of winter, the MONEX scientists turned their attention westward. By May 1979, a contingent of MONEX forces had set up a new operations center at Dhahran, at the edge of the Saudi Arabian desert. This was the first area to watch in the domain of the even more acute and spectacular summer monsoon. As the northern summer approaches, it is the Saudi Arabian desert, Pakistan, and the Indian subcontinent which begin to glow with heat. Responding to this heat, low-level air from the southern hemisphere crosses the equator and streams in jet-like currents into the Arabian Sea, forming strong westerlies near the southern tip of India. Often a vortex forms there and develops into a tropical depression. As it moves across the Arabian Sea, deep humid air masses penetrate into India, bringing the long-awaited monsoon rains to the western part of the country. Simultaneously, as the highlands of Tibet are heated, the prevailing upper-level westerly winds shift to the north of Tibet. The typical pattern of the monsoon circulation is now established. Over the warm waters of the Bay of Bengal, another development sets in. Vortices form periodically, which transform into great depressions. As they slowly move west, they bring heavy monsoon rains to the northern parts of India. This time, 4 specially equipped aircraft were brought into action. One began over the Saudi Arabian desert. Then, all 4 operated out of Bombay, and later, 3 flew out of Calcutta. The flight tracks were, as before, mapped out according to evolving conditions by the international MONEX scientific team. First, the heat sources over the Saudi Arabian desert and over the Indian subcontinent north to the Himalayas were explored. Then, the monsoon conditions over the Arabian Sea and south of the equator, and finally, the development of the Bay of Bengal disturbances. Vast areas of the Indian Ocean never probed before, covered by airborne soundings throughout the various development stages of the monsoon. Oceanography was to play an important part in summer MONEX. Here, on a turbulent sea whipped by the winds of the Somali jet, what were the actual changes over time in heat, current, and wave motion? What feedback was there from ocean to atmosphere and on the monsoon regime? Also, as part of the probe of the upper atmosphere, several Russian ships launched rocket-powered radiosonde probes. Out in the Indian Ocean, 16 ships rode the agitated waves during May, June, and July.
Which way are you commanding? Are you using
MONEX was not an isolated experiment. It was a coordinated part of the large-scale global weather experiment of 1979. There were 5 geostationary satellites positioned around the globe during the year. Along with 2 polar orbiting satellites, they were able to cover every part of the planet. For summer MONEX, one of the 3 United States satellites was carefully jockeyed into position over the Indian Ocean. The data from this satellite, picked up at Villafranca, Spain, were taped and sent for analysis to the Space Sciences and Engineering Center in Madison, Wisconsin, where satellite cloud observations could be translated into a moving picture of monsoon winds. From the Seychelles Islands off Africa's east coast, and from Diego Suarez on Madagascar, a French team began launching a series of transparent-skinned superpressure balloons to follow the low-level flow in the southwest monsoon and the Somali jet. Also watching and measuring were a battery of weather stations and weather radars throughout the region. Watching with concern because it was obvious from everything which could now be seen in the large-scale pattern that this was going to be an abnormally late monsoon year. The course of history in India, Pakistan, and Bangladesh on any scale, politics, religion, social evolution, law and order, is linked to the timing and intensity of the monsoon and its rains.
Further east, we have
The MONEX team in Bombay was also anxiously awaiting the onset.
which is not very well marked over 850 millibar. It'll be another 6-7 days.
Receptive, expectant, singing and praying, the people celebrate the coming of the rain. By mid-June, the monsoon made its dramatic entrance, bringing torrential rains to the west coast of India. Parts of northern India, however, were still without the rain that only the Bay of Bengal depressions would bring. In early July, the MONEX staff moved its operation to Calcutta to monitor the Bay of Bengal phase. As luck would have it, a depression was just then forming over the bay. The timing couldn't have been better. 2 research aircraft were able to probe a Bay of Bengal depression for the first time. The heaviest monsoon rains come from these depressions. These are the big ones that swell the rivers, overwhelm dikes and dams, wipe out young crops, and all too often kill people. However, they are also essential to agriculture and thus to life. By the end of July, with rain having come to most of India, the observation phase of MONEX was over. Several months later, at the National Center for Atmospheric Research, a panel of meteorological scientists met to review the preliminary results.
Active and break monsoons. And what I meant by stable is in sort of classical predictability sense. If you make a small perturbation, it's not going to be a different monsoon.
This information
The first products of the MONEX experiment were charts of upper and lower level winds, temperature patterns, day and night satellite pictures of the monsoon domain, and a wealth of organized data on sea surface temperature and the salinity of the equatorial Indian Ocean. The data that was gathered from myriad sources was brought to vivid life in a remarkable computer-generated monsoon film made by Professor T.N. Krishnamurti.
What you will see here is the first initiation of a convergence zone where these northerly flows meet with these westerlies, and the onset vortex forms on the 14th of June. Thereafter, you see it's gradually growing and beginning to move northwestward towards the coast of Oman. And it's a very well-defined vortex, as you can see from this film, with very strong increase of westerlies over the Indian subcontinent.
We have to understand
The completion of MONEX is merely a beginning. The data from the South China Sea, the Arabian Sea, the Indian Ocean, and all the surrounding areas, the atmospheric and oceanographic observations from balloons, satellites, aircraft, ships, all the measurements, logs, and charts are a rich resource which will be sifted through by scientists, analyzed and interpreted for years to come.
I mean, it looks like you can go further down and you can basically hit the source.
For something like half the population of the world, the monsoon will remain the most critical experience of their lives. The hope of science to understand the monsoon, to better forecast its timing and intensity, will not diminish